So today I'm going to be talking about the Euclidean algorithm, which is just a process to compute the greatest common divisor of two numbers. So I have an example down below, and we're trying to calculate the greatest common divisor of 9 and 24. So essentially, you're trying to find what is the greatest number that can divide both 9 and 24 evenly. So one sort of a naive approach would be to list out all the factors for 9 and 24. So I've done that, and then seeing, hey, what's the greatest common factor? So 1's a common factor, but there is another common factor if we're looking at the other ones, and the largest is going to be 3. So 3 is the GCD because it means that 3 can divide both 9 and 24 and result in an integer value. And so technically, if you wanted to find the GCD of any two numbers, you could list out all the factors and pick the greatest one that they both share. But the problem is if you are going to choose two really big numbers, such as numbers that are in the thousands place, it's going to take you forever to try to come up with all the factors. Like if you're trying to compute the GCD and one of the numbers is like 9,240, yeah, good luck trying to find all those factors. So the Euclidean algorithm is sort of a speedier process to find the GCD. So the first part of this video, I'm going to show just a formulaic approach on how to do it, and then the second part, I'm really going to visualize how does it work, why, which is also important to know, that way you're not just memorizing the process. Okay, but let's just do the process. So what you're first going to do is you are going to start with your biggest number, so 24 is greater than 9, and you are going to do some long division because you want to know how many times does 9 go into 24, 2 times, okay, remainder of 6. Alright, so you know from elementary math that you can rewrite any number by multiplication and then having its remainder. Or you can rewrite any long division problem as a multiplication with a remainder. Now what we're going to do is we are going to do a shift of our numbers. So 9 is going to shift over, and so will 6. Sorry, 2 should not shift over. Okay. So now we're trying to figure out how many times does 6 go into 9, and then what will be the remainder of the leftover. This is just another long division problem, way easier this time. Okay. We're going to keep going, so let's do another shift. Move over 6, and then move over 3. Alright, so how many times does 3 go into 6? 2 times, remainder 0. Alright, this is when we're going to stop. So anytime we get a remainder 0, we are going to look at the value, the line above it, and that is going to be our GCD. So the GCD of 9 and 24 is 3. Oops, this stylus sucks. Okay. And yeah, so this just shows that you can get the same value if you're doing the factors. But yep, this is a much speedier process. So why does the Euclidean algorithm actually work? And there's two main reasons. And we're going to use two sort of common math facts. One is that if you take the GCD of any number, of two numbers, you can subtract the smaller one from the larger one and take the GCD of that. So I'm talking about this right here. And the greatest common divisor will still be the same. So I still want to use our example with 9 and 24. So let me prove why this is true. So if we have some number A and our common divisor is d. N is just some integer. And we also have another number, b, with the same common divisor. Okay. And this is the same as having, if we're looking at our problem with 9 and 24, our common divisor we found was 3. So that's d. And then there's some number, you can multiply these to get to them. So in this case it'd be 3 and 8. And then since b is greater than a, 24 is greater than a, we're going to use this first formula. So b minus a equals dm minus dn. We can factor out this d value, the divisor. And so what this means is that b minus a is also divisible by d. And let me just rewrite that with our example to hopefully make this more concrete. So 24 minus 9 equals 3 times 3 minus 3 times 8. Factor out that 3. So 24 minus 9 is 15. And 15 still has a common divisor of 3, so this works. And so basically what this means is you can subtract these numbers from each other, like 9 and 20 from 24, and it will still have the same common divisor of 3. Actually, let's not erase that. Okay, the second important part is that if you take the GCD of n, which is any number, any integer number with 0, it's still going to equal n. So say we took the GCD of 3 and 0, this is going to equal 3. And you can think of that because if you write out the factors of 3, it is going to be 1 and 3. And if you write the factors for 0, it's 0 times anything will equal 0 still. So there's a ridiculous amount of factors for 0, and your greatest common factor is 3. So this is why that holds true. Okay, so keep those in mind, these two rules in mind as I go over this example. So we're still looking at 9 and 24, but this time I'm visualizing it with dots. So A is representing 9 and B is representing 24. And essentially what you're going to do is you're thinking about rule number 1, where you can subtract groups from each other and still have the same GCD. So I'm going to look at the bigger value and I'm subtracting the smaller group from it. So where are the common patterns of A and B? 9 shows up there twice, so I'm going to subtract that and we're just going to do our remainder. And this is the same as I showed in part 1 of the video. Here are 2 copies of 9, and now we're going to basically do the GCD of smaller groups. And we're looking at 9 and 6 now. Okay, so how many times does 6 go? We're looking at our smaller group now, which is B. How many times does 6 go into 9? There's 1 repeated group. We're pulling down our remainder. So now we have 6 and 3. So 6 and 3. Okay, so looking at the smaller group, how many patterns of A are there in B? There's 2 of them. Our remainder is 0. And now we can just take the GCD of these 2 things. So 3 and 0. We know from our second fact that this will be 3. So yeah, that's kind of the Euclidean algorithm in a nutshell, is you are just making these numbers smaller by subtracting the groups from each other until you get something with 0. And then it makes it super easy to find the GCD. So that's why your GCD will always be the line above, the remainder of the line above. So it's going to be 3.